Let us start lecture 49, and the course is on phase diagrams in single component and binary systems. And today's topic will be the graphical representation of del Hmix, which is enthalpy of mixing, and del Gmix, which is Gibbs free energy of mixing. And we will try to see when the system deviates from ideality, what would be the situation in a binary system, whether what composition we will have homogeneous solid solution, what composition will have phase separation, those kind of discussion will start. So, the main topic is enthalpy of mixing and Gibbs free energy of mixing when the system deviates from ideality in case of binary systems. Now, what we have seen in the last lecture is basically we have taken few conditions. One condition was when del Hmix is slightly negative, and another condition when del Hmix is slightly positive. And we have seen in those two conditions how the Gibbs free energy of mixing varies with composition. We have shown it with graphical representation. And in fact, we have also compared with the ideal one, where del Hmix equal to 0. Now, in all three conditions we have seen that Gibbs free energy curve with composition is vertically is actually convex downward, okay, all compositions. So, and when it becomes convex downwards, we will see gradually that the homogeneous solution formation would be the probable phase that would come out from a system. So, we will try to understand that part. At the same time, we will also see if delta Hmix is gradually increasing, what would be the situation on, what would be the effect on delta Gmix. That would also be discussed in today's lecture. Okay. So, let us start with those conditions. So, what are those conditions? First, let us write down all those equations what we have derived. Now, we have seen that delta Hmix, in fact, let me start with a binary solution. It is A and B, which are metals, and we have taken Na number of A, Nb number of B. When we add them together, it becomes 1 mole, which is nothing but Avogadro number. Xa and Xb are the mole fractions of A and B in the when it forms solution. So, that becomes 1 mole. Temperature and pressure are kept constant, and pressure is maintained at 1 atmosphere. Both the metals have same crystal structure. With same coordination number. And in fact, when we have solution formation, so that solution would also have the same crystal structure. And same Z, which is the coordination number. Fine. So, on this basis we have seen that delta Hmix equal to omega Xa Xb, and delta Gmix ideal equal to minus T del S mix Id, which is ideal, nothing but RT Xa ln Xa plus Xb ln Xb. And when we talk about solution for ideal is equal to G1 plus delta Gmix ideal, and in this case, so this entire treatment is divided into two parts. This part is right side is ideal, left side is non-ideal. So, this is non-ideal and this one is ideal, that is the condition we are taking, and here G 2 equal to G 1 plus delta G mix, where G 1 plus we can write this way, and in fact this quantity and this quantity are same, because there will be no vibrational entropy contribution or any other entropy contribution other than configuration, whether we consider non-ideal or ideal. So, in case of non-ideal we have used a regular solution model, regular solution we have taken. So, this delta H mix will be placed here, this omega x a x b. In fact, when we have considered omega, we have also taken delta x H mix to be we can write it in terms of this particular expression, where alpha is a parameter which can be related to omega r t. So, that is what we have understood, and alpha, the consideration of alpha actually helps us to actually, when we try to plot del H mix, we can actually take alpha to be some smaller quantities like 0 when it is ideal, it can be 0.5, 0.5, 1.0, 1.5, like that we can increase at a small number, and we can also have negative quantities also. Alpha can have negative quantity. So, accordingly we can express this del H mix in a small number basis. We will see how that small number comes up. Okay. So, we can actually now take it like this. Here delta G mix can be written as R t alpha x a x b plus R t x a ln x a plus x b ln x b. So, then I can convert this into this equal to alpha x a x b plus R t plus x a ln x a plus x b ln x b. We can put it like this. Another way, another one is delta H mix is equal to R t alpha x a x b. So, then we can write delta H mix divided by R t equal to alpha x a x b. Okay. Now, we will try to see the plot of this quantity and this quantity. So, that way we can actually reflect these two quantities over a small number actually, because that time we will have x a x b which are some fractions. Alpha can be taken as 0, 0.5, 1.0 as well as the negative quantities, the small numbers, and accordingly we can reflect how delta G mix by R t as well as delta H mix by R t vary with composition. Okay. So, that is what we are bringing in this alpha. Okay. Now, here also I can write delta G mix by R t equal to x a ln x a plus x b ln x b. Okay. We will try to see how that plot varies. In fact, when you try to look at delta G mix by R t plot, it is nothing but these two quantities, they are actually opposing each other when alpha takes positive value. So, that time how they vary with change in alpha, that will be shown. Okay. But in this case, In this case, it does not matter whether we in this particular case, in case of ideal case, the curve of delta Gmix by RT with composition will be always convex downward. But if alpha is positive value and as we increase the alpha number, then there could be a situation that the delta Gmix plot, delta Gmix by RT plot can become convex upward. Okay. Other cases, for example, alpha takes a negative value, the delta Gmix by RT with respect to composition will be also convex downward. So, we have 4 situations, we will try to see those 4 situations. Okay. And all those 4 situations could be like this, or case 1. Case 1 when we consider ideal case. In case of ideal, we will now try to reflect things with respect to alpha, alpha equal to 0. So, that case delta Hmix equal to 0. So, delta Gmix by RT will be reflected by XA ln XA plus XB ln XB. Case 2, we take non-ideal where alpha is less than 0. That time delta Hmix would also be less than 0 and delta Gmix by RT will be alpha XA XB plus XA ln XA plus XB ln XB, and delta Hmix by RT equal to alpha XA XB. Case 3, we can have a situation non-ideal where alpha is greater than 0, but small value. Okay. So, like what are those small value we can consider? 0.5, 1.0, 1.5 like this. So, that case delta Gmix will have the same expression, but here delta Hmix will gradually increase, or I can say delta Hmix by RT will gradually increase. Okay. If we take a small quantity, the small value, then this value also be small, small positive. Now, case 4, non-ideal, alpha greater than 0, but large value. We will see what large value it can have when delta Hmix by RT quantity would be also large. Fine. And that time we will see that the plot of delta Gmix by RT with composition, that shape would change from all the first 3 cases. All the first 3 cases, the delta Gmix plot with composition. So, if I try to plot that, this is delta Gmix by RT XB. If we plot, first one is, let us say this is ideal, So, that time alpha equal to 0. Then another case, case 2, this is case 1. Case 2 is this is delta Gmix alpha, let us say equal to 0.5, this is minus. So, let us say this is my delta Hmix by RT when alpha equal to 0.5. So, if we add this quantity with this quantity, so then delta Gmix by RT will further go down, okay, because from ideal, so this one part, this part is same whatever alpha consideration alpha we take. So, it will further go down, but when we talk about the third case where it would be positive, delta alpha is positive. So, let us say small positive, alpha equal to 0.5 and here it is minus 5, remember minus 5 the second case, but here it is a positive 0.5. So, this becomes delta Hmix by RT where alpha equal to 0.5, and that time my free energy plot, that delta Gmix by RT plot would be above the delta Gmix by RT when it is ideal. We have seen that in the last class. So, let us say this is my plot. So, this is the other one. So, this is nothing but the green one, the solid green one is delta Gmix by RT when alpha equal to 0.5, which is plus, fine. So, we can see that all three cases delta Gmix by RT plot, or we can actually take it as delta Gmix, fine, they are convex downward. So, we have to see what happens here. So, this one is not as simple as what we have considered in case 3. So, case 3 we have delta Gmix Hmix by RT is a small number, and since it is a small number and delta Gmix ideal by RT ideal is a large number, large negative. So, final contribution, which is the sum of that two quantities, will be also negative, but it will be little above delta Gmix ideal by RT. Okay. So, the fourth case will be an interesting one, but let us see all those first three cases. First three cases, can we decide the stability? Okay. Let us look at that. Now, deciding stability in case 1, case 2 and case 3. So, let us put the plot. The generic plot could be like this, this is 0, and remember here whenever we are plotting this one, remember this is 0, this is 0, this is pure B side, this is pure A side. So, that means x A equal to 1, x B equal to 1. Even if I miss that, please understand that two extreme points are pure metal sides. Here also this is pure, that means x B equal to 1, x A equal to 1, x B is varying this way, and the plot pattern is like this. This is the plot pattern, delta Gmix. Even if we avoid by RT, because that was done just to take things on a small number basis, but we can take delta Gmix, it will be always convex downward. Okay. Now, if I try to look at, let us say, at any point, if I try to see what will be the molar partial Gibbs free energy for mixing of component A and B in the solution. So, I need to take a tangent over this point, at this point over that particular delta Gmix plot. Okay. So, this length becomes delta G bar M B and this length become delta G bar M A. Fine. Now, we can write delta Gmix in terms of those partial quantities x A delta G bar M A plus x B delta G bar M B, and delta G bar M A can be written as R T ln A A, and delta G bar M B can be written as R T ln A B. Fine. We have seen this before. Okay. Now, just to look at these two expressions, and if we try to look at the plot of activity with composition, which is the mole fraction, that activity with the mole fraction plot also looks like this. This is x B. Let us say we are trying to plot activity of B. Here activity of B equal to 1 when it is a pure metal B. So, and this is 0. So, that plot, if it follows ideality, this will be my ideal line, that is A B equal to x B. Now, case 1 it will be, so you can say this is case 1 where gamma equal to 1, gamma B equal to 1. But let us say one such situation where gamma, for example, in case of case 2, since alpha is less than 1, so we can write gamma less than 1. Yes. So, gamma is less than 1, and case 2, case 3, gamma to be greater than 1. Okay. Fine. Let us say we are considering with reference to B first, let us say. So, then plot for case 2 would be this one, and this line indicates this is gamma B less than 1, and this line is A B equal to gamma B x B. In case of case 2 as well as case 3 would be the other one. So, this would be case 3. So, and then this line would be A B equal to gamma B x B, gamma B greater than 1. Okay. So, I can see in both the cases we are taking this one, both the cases if x B tends to 0, x B tends to 0, I can see using the Henry's expression A B also tends to 0. So, if this is the situation, then R is a gas constant, T is some finite temperature other than 0 Kelvin. So, this becomes minus infinity. Okay. So, what does it mean? In fact, if I try to look at this part, when x a tends to 0, a tends to 0, whether gamma is less than 1 or greater than 1. Okay. So, that time this would also go to minus infinity. And here we are talking about solution of A in B, and here we are talking about solution of B in A. Interestingly, in both the cases, when we go to a very low concentration of the solute, I see that this molar partial molar Gibbs free energy of mixing of let us say a component is nothing but minus infinity. It means that whenever we have such situation, a very dilute solution or let us say ultra pure metal, if we try to have some impurity there, here we are talking about the solute, let us say a very dilute solution of B in A, that means we are starting with ultra pure A, and then if we add little bit of B there, if there is a B environment, then even it is a small quantity, A would immediately capture B and try to mix it together, because the free energy change for the formation of solution is minus infinity. That means it is extremely spontaneous. Okay. So, it means that starting with ultra pure metal, it tries to form solution spontaneously, and this will be extremely spontaneous, rather I would put extreme spontaneity. Why? Because that solution formation free energy change is minus infinity, extremely negative. Okay. So, it will immediately capture B and form AB solution. Similarly, it applies when we start with ultra pure B. Okay. So, this particular information would be very critical when we try to go to a situation where alpha is a very high positive value, okay, or we can say del Hmix by RT is very high value, and there some composition range in between, there could be a possibility that delta Hmix by RT can actually have higher value compared to the mod of delta Gmix by RT ideal, okay, because when we talk about delta Gmix by RT of non ideal solution, that is nothing but delta Hmix by RT plus delta Gmix by RT ideal, because delta Gmix by RT ideal is nothing but minus minus T del S mix, which is same for both ideal as well as non ideal. So, that case we will see that if whatever positive values we can achieve for delta Hmix, there will be a situation at the extreme ends, that means the pure metal ends A and B, there would always be some dip in the delta Gmix by RT plot. Okay. So, that we will see later. Just I wanted to have this discussion that what happens when you go to extremely very ultra pure metal side and the solution formation. So, that is the solution formation becomes spontaneous. Now, once we understand that, let us see in case 1, 2, 3, since all the cases delta Gmix plot RT or delta Gmix versus XB plot, okay, that plot is convex downward, fine. So, let us take two composition of homogeneous solution before start of the experiment or start of the solution formation, global solution formation, or before the start. Let us say I take two composition of homogeneous solutions chosen from that delta Gmix by XP plot. How we are doing it? So, let us say this is 0 0, XB equal to 1, XA equal to 1, and in case 1 to 3 we see that the plot is like this. This is symmetric between two extreme ends. Okay. Now, let us say I take a composition here and I take a composition here, which is this is let us say midpoint XB equal to 0.5. So, this composition, two solution compositions are chosen in such a fashion that this is across this, in between, this XB is coming in between. So, let us say this composition is A, this composition is B. So, these are the two composition of homogeneous solutions of A and B, which is binary solution, and these are marked as small a and small lowercase a and lowercase b. We can actually connect them together with a straight line. Okay. So, this straight line AB line indicates that the free energy of the system considering solution A and solution B, and this is Xp which is going this way, and this is, remember, we always have kept temperature and pressure constant. Now, this can be, this straight line can be correlated with, if we realize, if you talk about the pure metal. So, let us say we have taken this one to be G A naught solid, and let us say this one is taken as G naught B solid. See, if I try to see the free energy before mixing of two systems, then I can just draw a straight line like this. You recall that. So, any point over this are basically related to the fraction taken of A and B. Similarly, here also any point over this AB line would be decided by the fraction of solution A and solution B, and the composition will be decided by, that particular composition will be decided by the lever rule of you have to apply lever rule, because we are actually balancing the mass of the solute content. Okay. Now, if we, but remember, this is not parallel to 0 0 axis. So, if we mix them now, mix and solution formation. So, if we mix and form a solution, and that mixing is done in such a fashion that equal fractions, or of course, fractions means weight fraction, then only you can apply lever rule. weight fraction of solution A and solution B are taken. So, that time you will see that, so the composition of the solution would lie at C point, and that C, if we draw a vertical line, that vertical line would actually coincide with the midpoint of composition. Okay. So, now we can see that when we have taken a composition of, let us say this is the composition of two solution, this is x b a, this is x b b, and this is the composition, let us say x b c. Fine. Let me put this particular point as D. Now, when we mix them, we need to see whether there is a drop in free energy, and if there is a drop, then definitely there is a spontaneity for the formation of that particular solution. So, now you see that once we have that mixture, before mixing it was at C, but now after mixing we see that there is a lowering in free energy, and it goes to the minimum point of delta G mix. This is delta G mix, minimum point there, and since there is a lowering, so the homogeneous solution formation becomes, solution formation is spontaneous. So, two solutions of different compositions, when we mix them and form another solution at a particular temperature and pressure, we see that homogeneous solution is forming, and that composition is taken as per the fraction of two solutions taken, okay, or weight fractions of two solutions taken, because we are applying lever rule and finding that solution composition. Okay. So, we could see that when the del G mix plot with x p is convex downward, whatever composition you take ranging from x p equal to 0 to 1, all the composition ranges will always find that when we mix those two solutions of different compositions, there will be always another phase that will come up, which will be of the same another homogeneous solution phase, which will have composition in between those two compositions. So, homogeneous solution formation becomes a spontaneous process when the del G mix is convex downward over the entire composition range. Okay. So, that is one important aspect. So, case 1 to 3, all cases, even if delta H mix is slightly positive, there will be no phase separation, there will be no clustering, there will be always a random solution formation. Okay. So, that is what the situation will be, but the situation will change if delta H mix becomes highly positive or alpha becomes a high positive value. Okay. And at some point of time, the delta G mix plot or delta G mix by RT plot will change its shape from convex downward to convex upward, and their situation will be a little complex. So, we will understand that complexity in our next lecture. Thank you very much.